I don't think so. I
Okay.
think what we've done is we've come up with very clever, very big sort of like black box fitting algorithms that you feed the inputs in and it will predict the outputs, right?
Yeah.
Um, and I've got a example of why I think this can't work. I think it's provably impossible, for instance, for us to get to artificial general intelligence
Using this
via this
framework.
approach,
Yeah.
as opposed to doing some useful things, which we
Mm,
definitely can do, right?
yeah.
But so basically, if you think about taking a brain, okay, and you're feeding it inputs and you're observing its outputs, and you've got a like an AI model of it doesn't matter what kind, but many billions of parameters or whatever. Now, how long would you have to measure the inputs and outputs of your experimental brain to be able to fit the parameters of this model?
Yeah.
And the answer is probably like the lifetime of the universe, right?
Yeah.
Because it's explosion of parameters. So it's an NP. It's what in computer science is called an NP hard problem, right? It
Right.
just explodes. You can't do it. So okay, slightly better problem, maybe. Um, you're not observing one brain. You're observing 6 billion, 8 billion of them,
Mm,
or whatever. Yeah, you've got a planet's worth of people generating outputs, we'll call it the internet, and you're observing that. But actually, it's still the same problem. It still doesn't scale well. I think you still
exactly.
have to
Yeah.
record for an ordinarily long sort of period of time, to be able to work. Now, you can asymptote towards something that might look okay
Yeah.
if you
Approximates.
don't probe too deeply.
Yeah.
And I think that's where we are now. We've got something that looks slightly better than ELIZA from the 1950s,
Hmm.
but it's but you probe it and it's not that deep. So I my feeling is that that's a kind of fundamental problem with our current approaches. Now, if you think about it further, like how maybe you can just scale further, maybe we'll get good enough, but actually we've already exhausted the data set, haven't we? The
Yeah.
internet.
Everything on the
Maybe,
internet.
maybe we can multiply the amount of data by 10. We're not, but to be honest, I don't think we can at this point because most of the stuff we're feeding into it is coming from it, so it doesn't count, right? So yeah, so I think we've saturated the data. So scaling is dead. So AI by scaling is now dead, pretty much, and that's acknowledged, I think, by many people in the AI industry, and they're sort of having these workarounds like agent models, etc. But I think that problem, the NP hard problem, is a fundamental one.
Yeah.
And so basically, I think a lot of people now acknowledge that that there is this problem. But whenever you look at kind of the solutions, it ends to my eye basically, and then some magic will happen. So,
There's still a big leap that
so
needs to happen, right?
yeah, so that's why I'm a bit of a skeptic. Now, having said that, I'm really just not um up to date with more than the coarse details of sort of the current AI architectures. So
Right. Right.
maybe there's something I'm missing.
Yeah.
I completely concede that.
Yeah.
But that's just my fundamental gut viewpoint that I think we're not really, we're basically just doing a large parameter sort of model fit on data which was generated by brains. We're not going to get to AGI that way. We will get to a bunch of useful things, which we're
Yeah.
already
There'll
doing.
be a lot of useful tools, but
Yeah,
not
exactly.
necessarily
So
natural
that's
language.
fine. It's still probably worth doing. Whether it's worth like burning the energy resources of our planet to do it is another question.
That's another question, right?
you know.
And we can touch on that later when we start talking
Yeah,
about ethics,
exactly.
right?
Yeah.
Okay, but I want to dwell on this a little bit, and again, I might not be articulating it properly, but so let's just do these quick jumps. We had these
Yep.
fairly simple machine learning where everything is kind of like a linear relationship. That
Yep.
was straightforward.
Yeah.
Then
Yeah.
we go into this neural network thing, which is many, many, many of these little
Yeah. And they've
linear
got little
units.
non-linearities in them, so
Yeah,
it
but
starts to.
somehow it understands handwriting.
Yeah.
And then
Yeah.
now we've jumped into you mentioned compression earlier,
Yeah.
this era of autoencoders and
Yeah.
transformers.
Yeah. Yeah.
And what they're essentially, and again, this is me or maybe oversimplifying, essentially modeling sequences of
Yeah.
stuff, right? Sequences of
Yep.
tokens, sequences of
Yeah. Yeah.
words.
Yeah. Yeah.
But in so doing, it starts to look intelligent. It starts to look like it can converse with you. It starts to look like
Yeah.
it can
Yeah.
draw.
It
Um,
it it, it
what's
starts
your
to look
impression
like
on
that.
that? Does that make even any sense? Like, or are we
Well,
just fooling ourselves
okay. But
looking at
firstly, I would say our brains have evolved to basically anthropomorphize things, right?
everything, right? Yeah.
Exactly. We look at like movements of stars and natural phenomena, and we ascribe, as I mean, even in modern era to some extent, but I mean, obviously historically, very much so. And we ascribe intention to them, don't we? I mean, we've evolved to find these forms of meaning, and I think of course we're going to do that in these LLMs. So yes, they start to look intelligent to us, but obviously, as you've seen many examples of, you can probe them and break the intelligent behavior very easily.
Right.
There are fundamental problems like the hallucination aspect of pretty much all generative models that we haven't got a solution for. And as far as I can see, I mean, the solution that's being used mostly is to have people checking the output
And we're back to
training,
like
and that doesn't
20th
scale
century
either.
stuff. Yeah.
Yeah, exactly. So yeah, I don't know. I'm a skeptic.
Yeah,